In the previous lesson, we talked about two different types of probability: independent probability and dependent probability. Last time, we focused on just independent probability. If you remember, this is when the outcome of one event does not affect the outcome of another. For example, we could spin a spinner and we could roll a dice. One does not affect the outcome of the other, and they can happen separately. Today, we're going to focus on dependent probability. Events are dependent if one event does affect the likelihood of the other event. For example, if I pull a marble from a bag and then I do not put it back, the probability of the second event happening is going to change based off of what color marble I pulled the first time around. The key here is going to be the word to not replace or to not put back. When you find the probability, you're still going to multiply the simple probabilities. You're just going to have to consider how the first event is going to change the second. Let's go ahead and go through one together. It says, there are 10 yellow, 6 green, 9 orange, and 5 red cards in a stack of cards turned face down. One card is selected, and then it is not replaced. That's the key word. It wants us to find the probability of each. The first thing we need to do is find how many total cards we have in the beginning. So we need to add all of our numbers. 10 plus 6 is 16, plus 9 is 25, plus 5 is 30. There are 30 total cards. So the first one says, what's the probability of getting a yellow card and then getting a yellow card? So we do have two events happening. In our first event, there are 10 yellow cards out of the 30 total cards. When you find the probability of dependent events, you solve the problem with the idea that the first event happened. So when we say we got yellow and then we want to get yellow, that means we got our yellow in the first time. So there are no longer 10 yellows, there are now 9 yellows because we drew it. So in our second event, we have 9 yellow cards left, and instead of 30, now there's 29 cards because one of them was not replaced. So now we can solve these. We always want to see if we can simplify before we multiply. You can see that we can remove the zeros from the 10 and the 30. We can simplify this farther by taking a 3 out of the 9 and a 3 out of the 3. That gets me a 1 and a 3. Simplifying it all the way down allows us to do quick and easy math. So we have 1 times 3, which is 3, and then 1 times 29 is 29. The probability of getting 2 yellow cards is 3 out of 29. On part B, we want a yellow and then a green. There are 10 out of 30 cards that are yellow. You always assume that you got what you wanted, so instead of 10 yellow, now there are 9. On the second part, we have green. There are 6 green still in the deck, but instead of 30 cards, there are 29. Now we can simplify down. We can cancel those zeros out, and then we can divide a 3 from 6 and from 3 to get a 1 and a 2. 1 times 2 is 2, and 1 times 29 is 29. On C, we want neither card to be orange. So if 9 are orange, that means 21 are not orange. So we want 21 not orange ones out of the 30 total. We assume that we got what we wanted. So now there are 20 that are not orange out of the 29 cards instead of 30, since we took one away. Now we can divide a 10 out of both 20 and 30. We can also divide a 3 out of 21 and 3. To get a 7 and a 1. 7 times 2 is 14, and 1 times 29 is 29. Let's go ahead and go through another one together. It says there are 8 shirts in your closet. There are 4 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday without replacing. Find the probability of each. The first one says that you drew a blue both days. So on day 1, we have 4 blue out of the 8 shirts. We assume we got a blue on the first day, meaning there's no longer 4 blue, there's 3. So we have 3 blue shirts, and instead of 8 shirts, we have 7 now. Go ahead and simplify down. We can divide a 4 out of 4 and 8. That gets me a 1 and a 2. So 1 times 3 is 3, and 2 times 7 is 14. Pause the video and try B on your own. On this one, it first wants to know blue. There are 4 blue shirts out of the 8 shirts. And then green. We assume we got the blue, so there's no longer 4 blue shirts, there's 3 blue shirts. There's still 4 green shirts, but now instead of 8 shirts, there's 7. Divide out the 4 from both the 4 and the 8 to help simplify so it's easier to multiply. You can also divide a 2 out of 4 and 2 to get a 1 and a 2. So we have 1 times 2 is 2, and 1 times 7 is 7. Now we have a problem with number tiles. It says a bag contains the following numbers. Without replacing the first, you choose a second tile. Find the probability of the following. There are 1, 2, 3, 4, 5, 6, 7 tiles. So A says find the probability of getting a 7 and then a 6. The probability of getting a 7 is 1 out of the 7 tiles. You always assume that you got what you needed, so the 7 is gone. It now wants to know what the probability is of getting a 6. There's 1 6 in the stack, and now since the 7 is gone, we have 6 cubes left over. So we can multiply 1 times 1 and 7 times 6. So the probability is 1 out of 42. On the second one, we have an even number and then an 8. If you look, 6, 8, 10, and 20 are the even numbers. So there are 4 even numbers out of the 7 cubes. You always assume that you got one. So then it wants to know what's the likelihood of getting an 8. There's 1 8, and instead of there being 7 tiles, now there's 6. We can simplify down by dividing a 2 out of 6 and out of 4. That gets me a 2 and a 3. 2 times 1 is 2, and 7 times 3 is 21. Pause the video and try C on your own. C says a prime number and then 9. 7 and 5 are the only 2 prime numbers, so we have 2 out of the 7 numbers. You always assume you got one. So now we have 1 9 out of 6 numbers. We can divide a 2 out of both 6 and 2 to get a 3 and a 1. So we have 1 times 1 and 7 times 3. This next problem says that there are tiles in a bag, you're not replacing the first one, and you're going to draw twice. Go ahead and pause the video and try A and B on your own. Now let's see how you did. It wants to know red tiles. There's 1 red tile out of the 7 tiles. You always assume that you got it. So now we want to know about blue tiles. There are 4 blue tiles, and instead of 7 tiles, there are 6 left over because you did not replace them. You can divide a 2 out of both 4 and 6 to get a 3 and a 2. 1 times 2 is 2, and 7 times 3 is 21. On B, it says a vowel first and then a green tile. A and E are your only vowels, so 2 of the 7 are vowels. We assume we got one. Now we want to know about the green tiles. There are 2 green tiles, and now there's 6 tiles instead of 7. Again, you can divide a 2 out of both to get a 1 and a 3. 2 times 1 is 2, and 7 times 3 is 21. Go ahead and pause the video and try this one by yourself. Now let's see how you did. We have 3 blue, 2 green, and 4 black marbles. That makes a total of 9 marbles. We're going to draw 2 out without replacing. We want to know the first one's blue and the second one's green. So we have 3 blue marbles out of the 9 total marbles. You assume that you got the blue marble, so now instead of 3, there's 2. There are 2 green marbles, and instead of 9 marbles, now there's 8. We can divide a 2 out of both 2 and 8 to get a 1 and a 4. And then you can divide a 3 out of 3 and out of 9 to get a 1 and a 3. So we have 1 times 1, and then 3 times 4, which is 12. So the probability of getting a blue and then a green is 1 out of 12.